The simple fact is how do you undo the fact that it's 9.8, you could say, meters per second, okay, over 1 second. If I change this 1 to some other number, I have to change the 9.8. I mean, it's just obvious. You can't break that ratio and say this is somehow second squared. It's not 9.8 meters per second squared. It's just 9.8 meters per 1 second. That's the end of the equation.
And again, nobody, literally nobody, not a single fucking scientist, physicist, or mathematician ever said that you have to square a number when it comes to the unit of acceleration. In physics, per second squared means something else. Acceleration is the change in velocity over time. The unit of velocity is meters per second, and the unit of time is seconds. So the units of acceleration are meters per second over seconds. Now your problem is that we now have twice the seconds component. We have meters per second over seconds, so we have 2 times seconds, and you say there is no need to write out seconds twice, because we already have the seconds in meters per second. There is no need to add another seconds to it, such that we have meters per second per second. But no, Gary. Here's a way to clear up that exact misunderstanding, step by step and without assuming any math tricks. Acceleration is how quickly velocity changes. If you double the time for the same change in velocity, the acceleration is half as big. That second per second is essential. Look at the units like fractions. Velocity's unit is meters per second. Now divide that by seconds again. Look at the fractions very carefully. It's not crapomatics, Gary. It's extremely simple, basic logic. Here is a step-by-step explanation how we arrive at seconds squared. Acceleration is change in velocity over time. Velocity already has the unit meters per second. Time for the change is in seconds, so the unit of acceleration is meters per second squared. This is often written informally as m/s/s. Rewrite the per as a single fraction. Think of per as division. Dividing by s is the same as multiplying by 1 over s. Combine the denominators. When you multiply denominators, you just multiply the units. That's it. No extra meaning, just 2 factors of second in the denominator. Use the exponent shorthand. Instead of writing s times s, we write s squared. And that's the standard compact form, meters per second squared. Key idea, s squared here doesn't mean time has 2 dimensions or square the number of seconds. It literally means seconds times seconds in the denominator because you divided by seconds twice. It's just ordinary fraction arithmetic. If you skip the second per second, you're no longer describing how fast the velocity itself changes, just the size of the velocity. Simple number example. Imagine a car's speed goes from 0 meters per second to 10 meters per second in 5 seconds. The 10 meters per second tells you how fast it ended up moving. The 5 seconds tells you how long that change took. Without dividing by 5 seconds again, you'd just have 10 meters per second, which is the final speed, not the acceleration. Everyday analogy. Think of earning money. Velocity like quantity, $10 per hour. Income rate. Acceleration like quantity. You increase your income rate by $10 per hour every hour. Unit, dollars per hour per hour. Dollars per hour squared. The second per hour is what tells us how quickly the rate itself grows. Bottom line, meters per second describes how fast you're moving. Meters per second squared describes how fast that speed itself is changing. The second per second isn't redundant. It's what converts a description of speed into a description of the change of speed.
That's the end of Newton's statement. There's no per second, and there's no per second, and there's no...
You don't even notice how hard you are contradicting yourself. So it's not meters per second? You literally write and say, it's 9.8 meters per second over 1 second.
The simple fact is how do you undo the fact that it's 9.8, you could say, meters per second, okay, over 1 second. If I change the fact that it's 9.8, you could say, meters per second, okay, over 1 second.
That's literally the same as saying 9.8 meters per second per 1 second. Tell me, what's the difference between saying 9.8 meters per second over 1 second and 9.8 meters per second per 1 second? Then you continue to say, it's just 9.8 meters per 1 second.
It's not 9.8 meters per second squared. It's just 9.8 meters per 1 second. That's the end of the equation.
Even though just before that, you literally said, it's 9.8 meters per second over 1 second. So which is it? Is it 9.8 meters per 1 second? Or is it 9.8 meters per second over 1 second? You just have no clue what you are saying anymore.